In this video I'll be talking about how to determine the length of the power line stretching from the top of the home here down to the power pole, given certain contour information. I like to highlight that when I initially made this model, which is made out of Play-Doh, so a model of a mountain, what you'll notice is that the Play-Doh is actually shrunk. And you can see when I initially traced out the contour line for the bottom, it was out here, and you can see now the Play-Doh is actually shrunk 2 to 3 millimeters, going all the way around. So if you're wondering why there's a discrepancy between the contour line here and the very bottom of the mountain, it is because the Play-Doh is actually shrunk over time. I've got the heater on inside the room, and as it loses moisture, the Play-Doh actually shrinks, unfortunately. So that's why there's a discrepancy between the contour line and the very base of the mountain. Now, thanks to my Monopoly game, what I've done is, with Monopoly we've got hotels and houses. What I've done is I've placed a house on top of the mountain, and on top of this house there's a bit of blue tack holding fishing line, which represents our power line, and I've got a needle here which represents the power pole. And what we're going to do is calculate the length of the power line, the so-called power line, from the top of the house to the power pole. Okay, so now I'm showing a side view of the setup I've got here. So looking at the setup from a side-on view, here I've got my house and I've got the power line running down to the power pole. Now if you look carefully, the power pole is located at 100, 200, 300, 400. So at an altitude of 400 meters. There's obviously a height associated with the power pole, which I've exaggerated here, and there's also a height associated with the house, which will be included as part of the calculation. So the question is, what is the length from the top of the house down to the power pole? So what is the length of this fishing line here? So I've got it zoomed in now, so I'll just reiterate what I've just mentioned, if I can get this to stay still. Okay, that's not too bad. I just want to bring it down a fraction. Okay, so I'll just repeat that again. The very peak here of the mountain is at 800, and an altitude of 800 meters, 700 meters, 600 meters, 500 meters, 400 meters, which is exactly where the base of the power pole is. Okay, now we've come back to the 2D contour map, and we're going to mark in the position of the power pole and draw a line representing the power line. So at an altitude of 400 meters we had the power pole located, which is right here. So I'll put P for pole, and at the very peak we had the house. So H for house. Okay. And all I need to do is join the two up to show the power line. So that's my power line there. The next stage requires us to determine the horizontal distance from the altitude 800 meters to 400 meters. And the way we obtain the horizontal distance is by measuring it using a ruler. Remember, we said that in the previous video that the scale is for every 10 millimeters represents 100 meters. So we place the ruler and measure the distance across. Okay, so I've placed my ruler and the power pole is located right here, which occurs at 35, 6, 7. So 37 millimeters. Okay, before we can actually begin the calculation process, we need to make a summary of all the information we know. So the height of the home is 4 meters. The height of the power line, power pole I should say, is 6 meters. And we know that the home is located at an altitude of 800 meters. And we also know that the power pole is located at an altitude of 400 meters. Okay, the next stage involves determining the horizontal distance. The horizontal distance from H to P. And the way we do that is on our contour map we get our ruler and actually physically measure it. So just place our ruler like so, making sure the zero lines up with H, and we take a measurement. Now it looks like it's 37 millimeters. So I'll just zoom in so you can see it, it's easy to see. So the pole, which is located right here, is approximately 37 millimeters. So from H, so from the home to P is 37 millimeters. Okay, so we've just obtained the horizontal distance, which we said was 37 millimeters. Now we need to convert that to real life unit. So a real life length. Okay, and we know the ratio is 1 to 10,000. So we simply multiply our 37 millimeters by 10,000 to give us 370,000 millimeters. Now we need to convert that to meters, so we simply divide that by 1,000 because there are 1,000 millimeters per meter. Zeros cancel out, and we're left with 370 meters. So we've just established that the horizontal distance from H to P is 370 meters. Now we can represent all this information on a triangle in order to complete the final calculation. So, got our horizontal line, got point P, actually we've got the elevation of 400 meters, we've got the elevation of 800 meters. Now we said that the house has a height of 4 meters, therefore we need to tack on an extra 4 meters. So therefore the final height is 804 meters. Similarly, we have to tack on 6 meters to represent the power pole, the height of the power pole. So therefore the final height here is 406 meters. And the diagonal represents the length of the power line, which is ultimately what we want to calculate, the length of the power line. So you can clearly see now that we have a right angle triangle forming. We know the distance, the horizontal distance, because we just calculated that, which is 370 meters. We know the height from here to here is simply 804 minus 406, which gives us 398 meters. Okay, so now we can actually determine the length of the power line. There's various ways we can do this. Probably the simplest way is to use Pythagoras' theorem. So Pythagoras' theorem which says L squared is equal to the base, which is 370 meters squared, plus 398 meters squared. Therefore, L is equal to the square root of 370 squared plus 398 squared. So L is equal to